everyone, and welcome back. Today we're going to continue multi-object systems, and we are going to go over a specific system called an Atwood's machine. Again, we are going to use the technique that I defined in my last video. 1, we're going to define our system. 2, make a second law equation for our system. And 3, redefine the system in order to find the missing tension. So one overall thing I want to point out is once you have the technique down, the system that is given to you will be pretty much irrelevant because what you are being shown are the traditional basic setups. But if someone is assessing you, they're going to want to give you something you've never seen before. So this is the traditional Atwood's machine. I have a frictionless massless pulley, mass 1, and a single string going over the pulley connecting mass 1 to mass 2. In this case, we're going to assume our givens are simply mass 1 and mass 2. So we know these. Our goal is to find the acceleration of the system and tension 1, which I will label right now. I have tension 1 here. This is a single string, goes over the pulley. Therefore, this has the same tension on the side. Side note, it does not matter where these two masses are. They could be even, one could be higher than the other. It doesn't matter. I put them at different heights just so when I draw on this, things don't get in the way. Now that I've marked my tensions, the next thing that we have to do is create our force diagram. So this is force Earth on mass 1, which is M1G. I have a force upward, which is tension 1. I have a force on mass 2, force Earth on mass 2, which is M2G. And upward, I have tension 1. Now, the next thing we need to do is to define which direction is positive. Earlier, things were just on a flat surface, so we made right positive, left negative. But here, this system could go one of two ways. Either mass 1 can go down or mass 1 can go up, which means mass 2 will do the exact opposite. So I'm going to say this way is positive. Now, that means that up is positive for mass 1, goes around here, and down is positive for mass 2. Once you make this decision, you cannot change it. And the fact that positive is a different direction for each of these is quite important. So the next thing I'm going to do is define my system. My system is going to be mass 1, the string, but not the pulley, and mass 2. So now I can make my second law equation. I start with the basics. Acceleration is F net over mass. Side note, F net is also written like this very commonly. It means sum of all forces. Okay, now since I made this direction positive, let's take a look at what I have. I'm going to start all the way here on the right-hand side. In the positive direction, I have force Earth 2, which is M2G. Now watch this. I have tension 1 in the negative direction here, but I also have tension 1 in the positive direction here. So what happens? All the same thing as last time. The two tensions will cancel because, again, they are an internal force and they are third law pairs, so they have to be the same value and they are in opposite directions for our system here, which means they are going to cancel. It would be negative T1 plus T1, so I'm not even going to bother. Then what do I have left? Here, force Earth on 1, which is M1G. So I have minus M1G. Now this net force is acting on how much mass? Well, it's acting on both masses because both masses are in my system. So M1 plus M2. That means this is my acceleration equation. And if you want, you can factor out G. So we now have acceleration in base terms, which is good. The next thing you want to do is get tension. Now to get tension, again, I have to redefine my system and I can't have both sides of this tension in the system. So I am just going to choose mass 1 first. And if I do that, I will have acceleration 1 is F net of 1 over mass 1. equals positive direction, T1 minus m1g over mass 1. Therefore, T1 equals m1a plus m1g. This would solve for T1. And again, this acceleration and this acceleration are the same. So you have acceleration of mass 1 because you have the acceleration of the entire system. I can also isolate mass 2 as long as I cut that tension in half. So for mass 2, acceleration of 2, net on 2 over mass 2 equals positive direction. Positive direction is m2g, force Earth on 2, minus tension 1 over mass 2. Therefore, T1 equals m2g minus m2a. So this would also solve for tension 1. So the technique is the same. Isolate your system, make a second law equation, then redefine your system as needed to get any internal forces. And your internal force is typically going to be a tension. Notice in this first case, you're adding mass times acceleration, and in the second case, you're subtracting mass times acceleration. That's to account for whether acceleration is positive or negative. If you look at mass 1, if acceleration is positive, then tension 1 has to be larger than force Earth. If you look at mass 2 and acceleration is positive, then force Earth has to be larger than tension 1. And the reverse would be true if acceleration was negative. Whatever acceleration you get for either of these, you would literally just put it in your final equation, whether it's positive or negative. So a good practice for this is to make up a mass 1 and mass 2. I suggest you make mass 1 a little larger than mass 2. That will give you a negative acceleration, which is perfectly fine. Take it, follow these steps, and you know you're good if you get the same tension 1 using both of these redefined systems. I think I'll create a different video for each of these multi-object systems, so I'll end this one here. I hope this helped you out. Have a good day. This is Mr. M signing off.